Alright, this is day 2. Let's continue practicing exploring polynomials, their end behavior, the degree, leading coefficient. We're going to classify them. We're going to evaluate them. So we're sort of tying it all together. Problem number 1. We're supposed to decide whether or not this function is a polynomial. If it is, we'll answer these questions. If it's not, we'll just move on. Is this a polynomial? Well, yes, it is a polynomial. It just doesn't break any of the rules. You know, a polynomial, the exponents have to be positive. They have to be whole numbers, like 1, 2, 3, 4, 5, 6, or even 0. But they can't be negative, and they can't be fractions. We can't have any x's in denominators. If I had like 7 over x or something, that would not be a polynomial. But this doesn't break any rules, so that is a polynomial. Standard form means descending exponent order. So the standard form would be f of x equals negative 7x to the 4th power plus 2x to the 3rd power. That's standard form. The degree is 4 because the degree is the highest exponent. Now the two-word classification. The first word has to do with the degree. If the degree is 0, meaning no variables, then it's a constant. Degree 1 is linear. Degree 2, x squared is quadratic. If it's 3rd power, that's cubic. 4th power is quartic. And 5th power is quintic. And then we also mention a word based on how many terms it has. If it has 1 term, that's a monomial. Because I should slide over now. If it has 2 terms, that's a binomial. 3 terms is a trinomial. And anything over 3, we'll just go with polynomial. Of course, all of them are polynomials. Even this little guy is a polynomial. So it can get a little confusing. Anyway, this is degree 4, so that makes it quartic. It's a quartic something. Since it has 2 terms, it's a binomial. So this is a quartic binomial. The leading coefficient is -7. Okay? If you write the polynomial in standard form, the leading coefficient will be in the front. Some kids make the mistake of putting down 2. Alright, the leading coefficient is always going to be with the highest exponent, no matter the order. Alright, look at number 2. Is this a polynomial? Nope. It's not a polynomial. You can't have negative exponents in a polynomial. So we skip the rest. Alright, so number 3. Use direct substitution to evaluate for the given value of x. Direct substitution is where you take the value and you actually substitute it for x. So that would be like this. So f at 1 would equal, if you take this 1 and you put it in like this. Okay. Now you really could do this particular one in your head if you understand that like 1 to the 4th power is just going to be 1. Because it's 1 times 1 times 1 times 1. And then 5 times 1 is just 5. Okay, 1 to the 3rd power is just 1. So I'm just going to have -8. 1 squared is 1. So really, this is quickly going to become 5 minus 8 plus 7. 5 minus 8 is -3. negative 3 plus 7 is 4. Okay, so the answer is 4. Okay, that's direct substitution when you actually substitute. Now, synthetic substitution is where we do this. We make a box, and inside the box we put the number that we're going to be substituting, the 3. Now we do the coefficients. Alright, I see the 2, the negative 8, the 5, the negative 7. The one thing you have to watch out for is, did we skip any terms? Looking at the degree of each term. Alright, looking at the exponents. I see a 4 and a 2, and this is a 1, and this is like a 0. Okay, so it goes 4, 2, 1, 0. Did we skip anything? Yeah, obviously we skipped the 3. So because there is a missing term, when we do our synthetic, we're going to think of this term as being 0 x to the third power put in here. So we will do 2, 0, 8, 5, negative 7. Okay, so 2, 0, negative 8, 5, negative 7. Okay. So, you bring down the first number. Okay, just bring it down. And then I do 2 times 3 is 6, and I put it here. Add these and I get 6. I start over. 6 times 3 is 18. So I put the 18. 18 and negative 8 make 10. 10 times 3 is 30. Together, that's 35. 35 times 3 is what? 105? Okay, so that's 105. 105 and negative 7 make 98. Okay, so that is 98. I feel like we did that same problem in our notes. Oh well. Alright, looking at number 5. Is this degree even or odd? And is the leading coefficient positive or negative? Well, when we look at the end behavior of this graph, the end behavior is the same as it would be for a parabola, right? I could draw a parabola right through this. So it has the end behavior of a parabola, and we know that a parabola is even, because that comes from x squared. So we know that this is the degree is even since both arms are pointing up. And we also know that the leading coefficient is positive. Alright, because it's an upward facing graph with the end behavior reaching toward the sky. If the graph looked like this, with both arms facing down, then that's what negative would look like. Okay, so even and positive. For what it's worth, this is a degree 4. I can tell by looking, when it makes this kind of a W shape, it's worth memorizing that this W shape is degree 4. Okay, draw a function with the same end behavior as f of x, and then state the end behavior in words and arrow notation. Okay, there are only 4 possibilities when it comes to end behavior. Either the end behavior is going to be like this, or it's going to be like this, okay, or it's going to be like this, or it'll be like this. All right, these are the only 4 possible ways that a polynomial can end. And so in class we talked about the fact that, let's see, let me make this chart. Okay, these parabolas, all right, they are even, okay, because you know this is like x squared. So all even degree polynomials will have end behavior like these. This is the model for x to the 3rd power, cubic, but it also has the same end behavior as any odd degree polynomial. So these are the evens, these are the odds, and the difference between them is up here these are the positive versions, and down here these are the negative version, like negative x squared and negative x to the 3rd power. Okay, so it's a matter of which one of these, when I say sketch the end behavior, I'm talking about drawing one of these 4. So which one of these 4 is it? Well, if you look at the degree, you see the degree is 5. That's odd. So that right away, that means it's going to be one of these 2. So I can go ahead and erase these guys, because it's not going to be that. Alright, so it's either going to be this or this. Now, between these 2, I look here and I see that it is a negative leading coefficient. So that means that we're going to go with the bottom one. Alright, so this is going to be the end behavior. So I can erase everything else. Okay, so that's the idea. Alright, now this 5th degree function, just to be clear, it doesn't look like this. A 5th degree polynomial will have more turns in it. It will have more waves. But I'm only talking about the end behavior. Okay, so if I'm just talking about the end behavior, the end behavior will look like this. So this is a good sketch for end behavior. Just for fun though, I'm going to show you what the a 5th degree model might look like. It might look like this. Okay, there's your 5th degree model. Right now you don't have to worry about that, but notice that it would have the same end behavior as this red one. Alright, anyway, on with it. So the end behavior in words. So with this sketch in mind, it's easy to see the end behavior. On the left it rises, on the right it falls. Alright, that would be the end behavior in words. Now how about that arrow notation? Okay, and here would be the same thing in arrow notation. On the left it rises, on the right it falls. So as x approaches negative infinity, f of x approaches positive infinity. Alright, that means left, this means rises. Asia, please remember that the beginning part of this arrow notation is always the same. The only thing that ever changes is the infinities on the end. If it rises, this will be positive. If it falls, it'll be negative. But all the rest of it is the same every time. Okay. Move on. Find the sum or difference of the polynomials. Well, let's be careful. When it's a subtraction like this, you have to distribute that negative sign. Let me zoom in a little bit. Alright, we will not just combine the like terms right now. Treat this like it's a -1 and distribute. Okay, like this. So that's going to give me -7x to the 3rd power plus 3x minus 7. Okay, and then we'll just bring down the other part. So the 9x to the 3rd power minus 4 plus x squared plus 8x. now we can combine like terms, all right? So, like terms. For example, the 9x to the third power and the negative 7x to the third power. Together, they make 2x to the third power. Notice that the x to the third power doesn't change. So that'll be 2x to the third power. Okay, any other like terms we have? Well, I see the x squared, but there are no like terms to match it. And that's the next power, so I'm going to go ahead and do that next. So x squared, I'm just going to put my plus x squared next. Okay. More like terms though. Alright, next we have the x term. So we have the positive 8x and a positive 3x. Together they make 11x. So plus 11x. And then finally the constant terms. Alright, so I've got this negative 4 and I've got this negative 7. Alright, together they make negative 11. So I'll have negative 11 on the end. So this would be the answer for number 7. Okay, number 8. Well, when it's addition, nothing changes. So the parentheses, there's nothing to distribute, not even a negative sign. So we can just begin combining like terms immediately. Let's see. Let's start with the highest degree. X to the third power. There are no third degree terms over here. So we'll just bring that over. Alright, so x to the third power. Alright, the next lower degree is x squared. I see x squared right here. There's nothing to combine with, so plus 7x squared is next. Alright, we'll just bring it over. Okay, then that brings us to the x term. Now, there are like terms there. So we have the negative 2x and we've got the 10x. Those are like terms, so we better put them together. 10 and negative 2, well, that's 8. So we'll have positive 8x next. Okay, and then the constant terms. Alright, the constant terms. So we have negative 3 and we have positive 17. So together that makes positive 14. So we'll have plus 14. Okay, that is it for number 8. Now for number 9, we have to multiply twice. Okay, so we're going to start with the x and we will distribute the x. Okay, like this. Alright, so that's going to give us, so x times x to the third power is going to make x to the fourth power. X times 2x squared is going to make 2x to the third power. Okay, and then x times 2 is going to make 2x. Alright, then we're going to go back and distribute the negative 1. So we'll do negative 1 times everything. Okay, so negative 1 times x to the third power is negative x to the third power. Okay, negative 1 times 2x squared is negative 2x squared. There are no like terms to match that up with. Maybe I'll just squeeze it in right here. Negative 2x squared doesn't line up with anything. And then we have negative 1 times 2 is negative 2. And that doesn't line up with anything either. Okay. So the only like terms I have are these. We have the 2x to the third power and the negative x to the third power, which is basically like a negative 1 x to the third power. So I will put those together. So I will have x to the fourth power, and then I will have 1 x to the third power, right? Because 2 minus 1 is 1. So I've got x to the fourth power, and then I've got x to the third power. So I'll put plus x to the third power. That's like a 1x to the third power. And then next comes negative 2x squared. And then we've got the plus 2x minus 2. Okay, always put your answers in standard form, descending exponent order. All right, now for number 10, please understand that this is the same thing as (4x minus 3) times 4x minus 3 times 4x minus 3. Alright, that's what it means to do something to the third power. Multiply it by itself 3 times. You cannot simply cube the two terms. You're going to have to multiply, alright, with the distributive property. So what I would recommend is start with the second two terms, alright? Start with these. Multiply these two together. Okay, so for example, let's take this 4x and distribute. Okay, if we do that, 4x times 4x, that is 16x squared. 4x times negative 3 is negative 12x. Alright, then we will take the negative 3 and distribute that. So negative 3 times 4x is negative 12x. Negative 3 times negative 3 is positive 9. Okay, I've got some like terms here that need to be combined. Okay, so I will have 16x squared minus 24x plus 9. Alright, so this is what I have. So I've got this trinomial. Now I'm just going to bring down the other 4x minus 3. Alright, I'm just bringing this down. Alright, and now I need to multiply by the 4x minus 3. So once again, I'm going to do that double distributive property. So I will take my 4x and multiply it by everything. Okay, just like we did before. So if I do that, 4 times 16 is 64. So I'm going to get 64 and then x to the third power. Okay, x times x squared is x to the third power. And now I'm doing 4x times negative 24. Alright, well 4 times 24 is 96. So I'm going to have negative 96 x squared. Alright, x times x is x squared. Then I'm doing 4x times 9. So 4 times 9 is 36. So I will have 36x. Okay, then I will distribute the negative 3. Okay, negative 3 times 16 is 48. So that's going to give me negative 48x squared. So I'm going to write that. I'm going to line those up. And then negative 3 times negative 24. Well, you know, a negative times a negative is a positive. And 3 times 24 is 72. So I'm going to get positive 72x. All right, and then negative 3 times 9 is negative 27. All right, so there we go. Combining like terms. So I'm going to have 64 x to the third power. Let's see, negative 96 plus negative 48. That's negative 144 x squared. 36 plus 72 is 108. So this will be plus 108x. And then we'll bring down the minus 27. Okay, so that is the final answer. Alright, which I will cut and paste onto the answer line. Okay, so there you go. Number 10. Alright, and number 11. Give an example of a polynomial function with degree greater than 3 that has the following end behavior. Okay, so let's make a quick sketch. You see the negative infinity and the negative infinity. So this is saying on the left it falls and on the right it falls. Okay, so we're talking about a polynomial that has this type of end behavior. Okay, obviously this graph would be like a negative x squared. But we're just focusing on the end behavior. So, so give an example of polynomial function. Now, I'm not talking about a sketch, all right? I'm talking about an equation. So we need something with this kind of end behavior. So if it's going to be have the end behavior like a parabola, that means it has to have even degree. All right, so I know the degree has to be even. But they said it has to be a degree greater than 3. So that means we could use the 4th power, 6th power, anything like that. So for example, let's see. I'm going to go with the 6th power just for fun. So I could have x to the 6th power. And but so far, if I just left it like this, that would be looking like this, end behavior wise. To make it this upside down situation, I need it to have a negative leading coefficient. So I could just put a minus sign in front. So really, this is the simplest type of function I could possibly make. This would satisfy the criteria. All right, it has even degree and it's downward facing, so this would have the proper end behavior. But I could put anything else on here I want just for fun. So for example, I could stick a 5 on here, and I could say like plus, you know, plus 3 x to the 4th power, you know, minus 7. Okay, I just made the red part up. So I expect you to make a function however you want, but as long as it has a negative in the front, and as long as the degree is even, and you know, bigger than 3, so 4, 6, 8, anything like that, then your answer would be right. Okay, that is the end of this lesson. Hope it was helpful, and I hope that you were not just copying off of me. Never watch a video with a pencil or a pen in your hand. Alright, I will see you on the next video.